All right, good morning, Zoom people. And of course, people in person. Alrighty, I am going to just jot down attendance and then we can go from there. Morning. Okie dokie. Alrighty, so today we are going to finish this lecture and then I have an assignment. And then Friday we will start the topic we were going to start today, which is about integrity and psychological thought. In theory, we have an exam scheduled a week from today. I will let you know Friday based on like how far we get, whether that seems realistic. Okay. I'll also make a review sheet and have it posted by Friday at the latest. Again, everything's just a little bit in flux because of everything going on. A couple things that will probably happen with the exam. It'll probably be similar to exam 2, where there'll be 20 matching instead of 10, just because again, we have a lot of terms this time around. And then, yeah, the same type of, here's a graph, what's good and bad about it, that type of thing. So other things you should be keeping in the back of your head are that your poster will be due the 3rd of December, which like sounds super far away, but is a month from today. So we'll spend some time in the coming weeks going over like how to make one of these and what is a good example of a poster, what's a bad example of a poster, things along those lines. Yeah.
I was wondering this last night and asked a question. So we have to do like both sides of the argument, and like data for people. But if we're doing like a myth that doesn't really have scientific evidence like against it, is that like I'm doing bipolar? People are like, oh, mood swings, like you're so bipolar, and like that is myth. But like there's no scientific evidence saying that people who have bipolar is going to be happy.
Sure, but there is scientific evidence saying that bipolar disorder is a disorder and not just something we should like casually throw around. Yeah.
I just don't have the other side, like, I don't have any data for those people who say that to support it, like.
Oh, yeah, and that's gonna be the case for most of the myths, right? Like, there's not gonna be scientific evidence, and that's kind of the point, right? So what you do is you talk about what the evidence is that people are using, which is probably not much, right? Their lay understanding of it, right?
I was just like, yeah, precise data for their support, like.
You will probably find, if you poke around online, someone who's made a bad data visualization or something like that, right? Yeah, that's a good question. I've yet to decide if we're actually going to print the posters. I may just have us like show them up here and y'all present them that way, just because it's a little bit of a headache to get them printed now. It used to be we just had a printer and like you send it to the copy center and they print it, and it broke and they never replaced it. So now we have to go through an outside company. We have to give lots of lead time, and I'd rather give you guys more time to like perfect your posters. So we'll work it out when we get there. Any other questions about stuff coming up, logistics, things like that? Alrighty. So again, for Friday, if you haven't already, read your book chapter 7 and the perusal readings and do your perusal comments. Alrighty. All right, so we ended here on Monday. We were talking about how putting multiple axes on a single graph is not a good idea. So There we go. Oops. And again, if you look at this, it's just super confusing, right? Because you've got 3 different types of data being visualized on one graph, right? That are kind of related, but like on different scales, and it just gets super confusing, right? The other thing, and until I was prepping this PowerPoint, had literally never seen this, but apparently this does happen, or people will just change their x-axis halfway through. So I don't know how much you guys can see this because it's kind of light, but until you get to this point, the increments are 10, 10, 10. And then this was pretty close, right? You get to 999, and then all of a sudden, even though these are still equal increments, they're like doing it by decimals. And I think they're trying to like blow up this part to show the amount of change they had for that income group. But what you should have done then is gone to 100, right? And then you'd have an uprise, and then done a second chart just for this, right? Just to visualize that last bit. Because again, it gets confusing, it's misleading, it's problematic. Another thing is just to use languages or labels, sorry, on axes, right? So this like kind of has them, kind of not. It doesn't really necessarily make sense, right? Like the languages don't necessarily like incrementally go up, right? It's just bizarre. Like this should probably be a bar graph, right? Like it just doesn't make sense. And you could have put the languages on the x-axis and then the percentages on the bars, right? So yeah, again, sometimes people try to get cute and fancy and they will just make things that don't make sense, basically. This is again something that I think I've only seen once or twice, but it's sort of like a haul. Sometimes people will actually invert the axis to be misleading. So you see the number of murders committed using firearms. If you just glance at this and want to read it like a normal chart, right, then you'd want to read this area. But they're starting at 0 up there. So in fact, what you should be reading is this area. And in fact, what they should have done is just flipped the red, right? And so what they're trying to suggest is that the number of murders in Florida went down after the Stand Your Ground law, when in fact the opposite is true, right? And in fact, it went from less than 600 to over 800. Now, are those directly related? Maybe, maybe not, right? Correlation does not equal causation. But again, it's a way to mislead with existing data. The second reading you had on perusal was about the principle of proportional ink. And so this is basically, like taking 2 steps back, right? If we look at the shaded region, the red region of this chart, right? That's an example of a shaded chart. So when a shaded region is used to represent a numerical value, the area of the shaded region should be directly proportional to the corresponding value. Seems to make sense, right? And again, if we read this correctly, this one does that, right? If you read the red rather than the white, this one is doing that correctly. But a lot of times, again, especially when people try to get cutesy and use like figures instead of actual bars, you'll end up with really weird things that are not proportional. So again, they talked about bar charts. The axes need to reach 0 and be proportional. So here, if you just go from here up, they are. Like if you were to just ignore this bottom part it's actually a good bar graph. It starts at 0. The filled-in part is proportional, right? But then you look down here, and again, they're just trying to be cutesy, and so they label their x-axis with things that look like books, which again, great cutesy, but then makes it look like, the Diary of Anne Frank is much more proportional to the Bible than it actually is, right? So again, if they had done this chart and just put the titles underneath right here, it'd be a perfectly good graph, right? It wouldn't be as cutesy, but it'd be accurate. But because they have filled these in with the same color even, they're violating the principle of proportional ink. Because it looks like, basically it's not proportional to these actual differences. Again, everything above that 0 x-axis is proportional, but when you add in the stuff below, it's not correct. So line graphs, if the line graph is filled in, again, like our red and white one that we looked at, or like this one here, the axis should go to 0. And again, you should make sure you're accurately representing it. So here is a, again, bad example where the x-axis is starting, or y-axis, sorry, is starting at 28. And so it looks like the tax rate is very dramatically going down, but in fact, it's only varied about 8 points, right? Whereas that looks like 80 points, right? If you look at it sort of out of context. So this is violating that principle of proportional shading. Oh, bubble charts. Bubble charts are really in right now. And I don't know if I put an example. I did not. All right, let me real quick just show y'all an example of what a bubble chart looks like in case you haven't seen one. There another thing. Yeah, here we go. That is like super cutesy, so people like it for that reason. And it's like they're trying to use for the principle of proportional ink, where it's like Michigan has more property crime than Illinois, so their bubble is bigger. But it's like still confusing, still problematic in some ways. And let me go back to the slide here to explain more why that is. So if you're using these, color and size can actually help. Vertical and horizontal position are useful. So you basically show 4 attributes of data for each point. But the problem is it's difficult to judge the relative size of those bubbles. So if you think about the one we just looked at, like the Illinois bubble was slightly smaller than the Michigan one, but like how much smaller? Humans are not necessarily good at looking at circles, say, and telling how different they are, right? And we have optical illusions based on this, right? They also need to be very carefully labeled. So just personally, I don't like bubble charts. I think they could probably be done well, but it's just, again, it's like trying to be cutesy when there's probably better ways to represent the data. Again, this was new to me. I've heard of bubble charts, but not this until I was doing this. This is called a donut bar chart. And so basically, if you just kind of flip this and imagine that this is your x-axis, right? And then you straightened out these bars, it would be a basic bar chart. But instead, to try to make it look fancy, they wrap it around in a circle. This exaggerates the existing differences, or it can also conceal them, right? Like these two could be decently different, but because they're curved, we can't really tell, right? It sort of skews it. So again, this is an example of trying to be fancy. And like the other problem with donut bar charts is that people start to interpret them like a pie chart, right? Because we're used to circular things representing percentages. And in fact, maybe not, right? Oh yeah, this can be problematic too. Sometimes people will report the actual numbers. Sometimes people will report percentages or fractions or decimals of things. And it can be intentionally or unintentionally misleading. So, just visualizing your data in the simplest way possible, essentially. 3D charts in general, this I think was like late 90s, early 2000s. These came out on Excel, and it was like everyone wanted to use them because, again, they looked fancier, right? But like they're not actually that helpful, right? And especially if you're trying to think about something like the principal proportional ink, based on how they have to be represented, it can just be misleading. The angles of it can make things problematic. So it can be confusing and overwhelming. Sometimes it can be straight up BS. So if you only have one independent variable, you only have essentially an X and Y axis, that's how you should be representing it, right? As soon as you add that 3D quality, it sort of suggests there is this, third variable you're accounting for, a Z, right? Another issue that they show here is that the end caps of the bars make them look longer than they are, right? So am I supposed to think the data stops here or the data stops here? And they're not that different, but it certainly makes a difference in how we interpret it, right? And like, yeah, the other bars also influence the size of these things, which can sort of skew things. So it's really not following proportional ink. This, again, like I've seen these. People love to do these and they're unnecessary. But this was something I never seen before. This is kind of similar to the donut bar graph. Again, just trying to be fancy, trying to be cutesy, bending it up a wall. Like, I don't know why. Like, why? What good does this do? Right? It makes it harder to assess the relative sizes. And because of perspective and foreshortening, objects along the line of sight appear shorter than those perpendicular to the line of sight. So that's gonna skew how we interpret it. And this is particularly troublesome when it's not like a right angle, when there's sort of a curve like here, right? All right, and then pie charts. So it's really interesting. So basically everyone, and there are, like I said, multiple of these websites that point out bad charts and graphs. Every single one of them hates pie charts, which is really interesting because they're really popular, especially in like business presentations, right? But simply because they're often done poorly. And I really liked this figure here. So this is the percentage of pie charts that do not show the data clearly. 100%. The percentage that can be replaced by bar charts, 100%. Same thing as donut charts, and probably unnecessary. Again, does this mean people will stop using them? No. Does this mean they're never helpful? I don't think so. I think if you have basic percentages that are big chunks, it can be pretty helpful, right? One of the things that they talked about is that just like bar charts, they are sometimes done in 3D, like this example here. And again, that's messing with the principle of proportional ink, right? Because it looks like the one that's sort of closer to you has more area. So they're hard to interpret and they're often done incorrectly. One of the things I like that a website pointed out is, again, with the software that will do this for you, one of the ways you can do it is kind of like to explode it so the pieces are not connected. And they're like, how do I fix a bad bar chart? Pie chart, I just explode it, right? Like, okay. The next part, if you printed these out the other day, was not there because I added this morning. I was like, let's give you some examples of how data is visualized. And these are all from my publications. I'm not saying I'm the best ever at data visualization, but the vast majority of these publications were when I was still in graduate school. So I was like under the supervision of a very adept PhD person. And I want to show you how boring they are, right? But how like that's how it goes. So this is from one where I believe I was second or third author. And you get, and this is just a table, right? A lot of people don't want to do tables because they're like, oh, it's just a bunch of numbers, blah, 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 blah. But sometimes it's the best way to do things because we've got a lot of information jammed into what, like if we did a 3D bar chart, right, would give us like maybe 2 columns of this, right? So these are all the questionnaires people filled out. Down here in the key, it tells you what those are. We've got the mean score for the sample and the standard deviation, that measure of variability. We've got the Cronbach's alpha, which is a measure of internal consistency. It's essentially how much each scale, the items like relate to that scale, and like correlates all the items among themselves. Anything above 0.8 is considered good. Anything above 0.9 is considered excellent. So we're doing great here, right? And then this is a correlation table of all the variables with each other. So now we know how each of the variables relates to the other for this whole data set. So for example, I think I've told you that in the midst of coding for a meta-analysis right now, I could get at least half of what I need to code for a meta-analysis from this table. Whereas if you don't have a table like this, I might have to dig through your results and your method and things like this. So I always love when authors have these. Again, they're not the most visually like exciting, right? But you pack a lot of good information into this, right? Like I want to see how body image quality of life is related to body mass index. Look, it's right there. Boom, right? And I can do that for any 2 variables in this data set. And down at the bottom, this information also gives us the P level. So, you know, whether it's less than 0.05, 0.01, or 0.001. For this data set, we also indicated if it was less than 0.10. That's sort of controversial within the field of psychology. But because P is less than 0.05 is pretty arbitrary, some people will report if you are less than 0.10. Essentially, if there's like less than a 90% chance that, like you have a 90% or more chance that this didn't happen by chance. Exactly, yep. So they're just little asterisks. So like this one has 3. So that means that P was less than 0.01. So there was a 99.99% chance that this did not happen on accident. All right, this is from a study I did where we had people come up with word stems. So we gave them like the first 3 letters of the word, and then they had to figure out a word. And what we were trying to get at is, are they going to pick more appearance-related words if they are someone with an eating disorder? And yes, they did. So here's the people with an eating disorder. Here's the control subjects. And then we also looked at just the control in general. We're more likely to come up with non-appearance related words. So again, you get a lot of information from this one pretty simple bar chart. The bars up here tell you the variability, basically. The bars here with the stars show you which differences are significant. Again, not that exciting, pretty simple. I think I made this in Excel in like less than a half hour, right? But gets the point across. This is another one. This is, I believe, from my dissertation. Yeah, my publication, my dissertation. And so this allows us to look at 3 variables together. And this is, we were looking at whether someone made a comparison to someone they thought was more attractive than themselves. That was what we call an upward comparison. Or if they made a comparison to like anybody else, someone who they were like, yeah, that person's as attractive as me, or like, no, I actually look better than that person. And then we were looking at body dissatisfaction. And then we were also looking at level of feminist belief. So one of the things I've studied is whether holding feminist beliefs is protective against some of this stuff. And so really interestingly, if you made a comparison to someone who was as attractive as yourself, or you thought you were more attractive than, it did make a difference. You experienced less body dissatisfaction than people who were lower in feminist beliefs. But if you're making those comparisons to people who you think are more attractive than yourself, it's like literally the same point, right? So again, pretty simple chart. Because it's a line chart, it's okay not to go down to 0 so that we can accentuate this difference. But also means that, like, again, with a couple lines, we get a lot of data, a lot of information, right? Here's where we get a little more complicated in the published figures. So psychology and other social sciences have developed complex statistical techniques to try to look at how a bunch of variables might relate to each other simultaneously. And so this is a variation of that called structural equation modeling. And so basically, you tell the statistical program, look at all these variables at once in this way. And the program I use actually lets you draw it, which is really cool. And then each of these values is how these paths relate. And then this is like how much error each has. So again, more complicated, a little more visually appealing, but tells us a lot of information we need to know. You can also have other helpful figures, right, that just sort of illustrate things in your studies. So I helped supervise a study with a high school student, actually. I was really impressed by her, who was interested in doing a psychology study for her science fair. And we ended up publishing it because it was so good. And so she took Barbies and then Tracy Turnblatt from Hairspray, and dressed them in either modest clothing or bathing suits, and then gave them to little girls 5 to 8 to play with, and saw how the girls reacted. And so it was really helpful to have like an illustration of these figures, right? This is maybe my favorite figure I've ever made. This is from that one where they were doing the word stem. And I had a really pretty figure with like an actual picture of the Palm Pilot we used. And the journal was like, ooh, we don't know if we can do that because of copyright issues and like trademark issues. So I made this in MS Paint. It's published in a journal somewhere, which to me is just hilarious, right? So, but it demonstrates what the participants saw on the screen. So the first screen, they got the word stem. The next screen, they got to choose the word they thought of. And so in this case, lean was the appearance related word, for example. But they might have thought of these, or they might have thought of something else altogether. Alrighty, so that is it for that lecture. And then the assignment for today is going to be something y'all just sort of do with groups, like on whatever paper you have, or you have your computer and you want to use that, you can. So this is, again, something I constructed this morning. This is yesterday's election results from Virginia. And I want you to kind of group up, and maybe we can do 2 groups in here, however you all want to split, maybe just like along this line. And if with your group, try to figure out what would be the best way to visualize this data, right? So this is what you'll see reported most places. But then I also thought it was important to look at the voter turnout rate, which I couldn't find reported yet. So I actually looked up on the Virginia Department of Elections how many registered voters there are, and then added up how many people voted. And actually 55% is not an awful voter turnout rate, but like, gosh, isn't it sad that almost half the people who are eligible to vote didn't vote, right? So go ahead and group up with your groups, and then people who are on Zoom, I'll go ahead and put you into 2 breakout rooms. And I will give you the link so that you can see this even when you're in the breakout rooms. And just come up with what you think would be the best way to visualize this. Hang on just a sec. Throw this in there. It could be a bar chart, it could be a pie chart, it could be something else altogether, it could be a table. Here, I'll close this so y'all can actually see the numbers, that'd be helpful. Yeah, if you can, and it doesn't have to be super pretty, like, you know, you can just like draw it in your, like, there, that's fine. Yeah, go ahead and draw it out, if you figured out what you want to do.
Okay, so we decided like maybe a pie chart at least for like voters. But I was thinking of like a bar graph maybe. So one bar blue, one bar red, one bar gray for people who didn't vote, and like on the X and Y axis, like the number of registered voters, and then like you could that way you could see who all voted and all that stuff. So.
Yeah. So maybe that becomes one graph, or maybe that would even be two. Yeah, but I like that idea. All right, how about Henry, Jaden, and Oliver? And don't make Oliver talk because he is dealing with what I'm dealing with. Go ahead, Jaden, sorry.
No, you're totally fine. We also discussed doing a pie chart, and we talked about specifically the labeling and how it would be best to do it like more simplistically and then have like more information and a key to make everything more readable.
Sounds good. All right, so to be perfectly honest, I expected this to take a lot more time than it did. So that's everything I had for today. Any questions about anything? It seems like you got it. It's pretty straightforward. Cool. Well, everybody can head out a little early today then. Excellent job. And then we're going to start talking about the integrity and psychological thoughts on Friday.